Okay, before the timer started counting the time, I have to thank Howard because he provided a very basic introduction for the topic I was going to Actually, I have already been afraid of that my introduction was going to be too difficult. But since Howard has already told you the very basis of the genetic research, so I believe that I can go further for the introduction. Okay, just give me. Ever since the start of biology, the people were all fascinated about one question. What is the origin of sexual dimorphism? Or, in easier words, what is the origin of the differences between males and females? So in order to answer this question, people usually turn into simpler form of life. So this is the journey I would like to introduce you today, and maybe I can review some clues we already found. Actually, the model organism we chose here is the Drosophila monogaster, which is a kind of fruit fly. And why this fruit fly is so special? It is because it has a very unique feature called sex comb on its leg. And the sex comb only exists on the male Drosophila monogaster, and it doesn't exist on the female Drosophila monogaster. So the function of it is not important, but you can view it as a very good example of sexual dimorphism. So our great question turned into, what is the origin of the sex comb? After a long time's research, we already find that a gene called double sex has large to do with this. And we already find that the double sex gene is to establish the differences between the opposite sex. What does this mean? Which means, wherever there's no double sex, the leg of the Drosophila would exist in some kind of intermediate state. But when the double sex male form comes along, it will appear, the sex comb. And when the double sex female form comes along, the sex comb will totally disappear. So we believe that this process defines the different appearance of different sexes. However, we also find another thing, and it is quite tricky. We find out that the other fruit fly species expression, the double sex expression is correlated with the sex comb. Not only in the target, so-called monogaster that we are looking into, but also in the closely related species, such as this, and this. And we can also find that the sex comb form is quite diverse and look different. So here raises the question, does a double sex gene simply establish the differences between opposite sex, the males and females? Or actually do more? It can play a role in a global full-scale control to the gene expression. This question has long been a big issue for the scientists, and we had already spent a lot of time on it. Until recently, we find out another clue. We find out that another thing called cis regulatory elements has something to do. It is a key for us to control the double sex gene. How does it do? The cis regulatory element is actually hidden inside the double sex gene itself, and it can control the double sex gene expression, either suppress or enhance. So we can say that if we are able to find out the precise position of cis regulatory elements, we are able to control the behavior of double sex gene. So let me give you a short summary about my speech here. What we are interested about is the sexual dimorphism, and we know that a sex comb is a good example of sexual dimorphism. And also we also know that double sex has large to do with the sex comb, and the cis regulatory elements is a key for us to control double sex gene. So the final question narrowed down into, we need to find the precise position of the cis regulatory elements. How do we do? So, first, imagine there's a gene. And Howard already introduced all of you that the gene has the intron, which means the non-coding region, and the exon, which means coding region. So, the coding region has nothing to do with the double cis regulatory elements. So what we are interested in is about the introns. So we first use the skills to copy all the introns out. And then we fuse these introns with different GAF4. GAF4 is just a name of a molecular tool. You just only need to memorize it for a very short time. So we fuse it with GAF4 and then insert them into different strands of molecular gasters. And then we create different intron GAF4 line lines. And we further cross them with the UAS GFP line. This is another molecular term. You just need to be remember it for a very short time. We then further collect the F1 generation only, which means first offspring generation. The reason the process seems very complicated, but the purpose is quite simple. Because we want the introns and GAF4 and UAS and GFP appear in a single organism simultaneously. So, if the intron has the cis regulatory elements on it, then it can activate GAF4, and the GAF4 is able to activate UAS, and UAS is able to activate GFP. And here it will come out the green light called the GFP light. So the whole process builds a bridge between the existence of the green light and the existence of the cis regulatory elements. It is just amazing. It is simply amazing because it can build a bridge between the invisible molecular behavior to the visible green light we can observe. So that if we find the green light, then we can know the precise position of CRE and the CRE, and we can be able to control double sex, and the double sex is the key for the sex com, and if eventually we can find out the origin of sexual dimorphism. So, what do we find? Actually, we do find that in the intron 2, intron 3.1, there is a green light comes out. And luckily, its pattern is quite correlated with the antibody standing reference. So which means it's a very good clue for us. So we can conclude that the cis regulatory elements do exist in the intron 3.1. So does it mean that we already find the answer for the sexual dimorphism, the origin? Well, I have to say I have to stop here. Because you are already in the frontier of science. This result is just published 2 weeks ago. However, life is the science is a long journey, and maybe all the things I have introduced here will prove to be wrong. However, it doesn't matter, because it is always the curiosity and excitement for us to keep us and inspire us to keep going on. This is exactly the essence of science, and so is our life. Toastmasters of the evening.